Hello, everybody. I can determine whether three numbers can represent the sides of a triangle and find the range of possible values for the third side of a triangle using the triangle inequality theorem. What the triangle inequality theorem states is, in a triangle, the two smallest sides must be the smallest sides, must add be larger than the third side. So, which of the following cannot make up the three sides of a triangle? For each choice, I'm going to add the two smallest sides, and they must be larger than the third side. Not equal, but larger. So my two smallest sides in choice 1 are 3 and 4. Is 3 plus 4 greater than the third side? Yes. 7 is greater than 5. That can be the three sides of a triangle. My two smallest sides, 2 and 2. Are those greater than the third side? Yes. 4 is greater than 3. My two smallest sides, 5 and 7, is greater than the third side. Yes. 12 is greater than 9. My two smallest sides, 1 and 4, is greater than 6. No. 1 and 4 is 5. 5 is not greater than 6. To determine if three sides can make up the sides of a triangle, the two smallest sides must add to be larger than the third. Which of the following can make up the three sides of a triangle? Well, the two smallest sides, 2 and 2, must add to be more than the third side. Is 2 and 2 more than 4? No, it's equal to 4. It must be larger than 4, so that one's out. The two smallest sides, 1 and 4, must add to be larger than the third side. 1 plus 4 is 5. That's not more than 7. The two smallest sides, 1 and 6, must be greater than the third side, 8. 1 and 6 is 7. 7 is not greater than 8. The two smallest sides, 5 and 5, must be greater than the third side, 7. Yes, 10 is greater than 7. That one's true. That one's your answer. Now, there's another application of the triangle inequality theorem, and that's where we can use it to find a possible third side, given two sides of a triangle. So in triangle BLA, BL is 12 and AL is 8. What is the range of possible values of BA, the third side? You don't have to draw a picture, but it's never a bad idea to. BLA, BL is 12, AL is 8. Here's how we find the range of possible third sides for the range of possible sides for the third side. We find the sum, we find the difference of the two sides I already have. So I do 12 plus 8, I do 12 minus 8. 12 plus 8 is 20, 12 minus 8 is 4. So it could be anything more than the difference and less than the sum. So the way we write that is 4 is less than, let's just write x is less than 20. And what that means is it could be any value that's in between 4 and 20, but not including 4 and 20. So 4 does not work. 4.000001 would work because it's more than 4 and less than 20. So as far as integers go, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 all work. 4 and less don't. 20 and more don't. So the answer is this. In triangle CAM, CAM is 10, CA is 4. It wants the range of possible values for MA. So why don't you pause it and try it on your own, find the sum, find the difference. It's everything in between those, but not including. Now that you tried it on your own, I'm going to find the sum. I'm going to find the difference. 4 plus 10, 10 minus 4. It's going to always be positive, so when you're finding the difference, just subtract the bigger minus the smaller. I have 6 and 14. So my range of possible values is in between 6 and 14. I don't know if you need to know this notation necessarily, but understand that it's all values in between 6 and 14, but not including 6 and 14. Which brings us to one more spin-off of this. Two sides of a triangle are 7 and 11. You don't need to draw the picture, but it's always a good idea to. So the third side, well, let's find the range of possible values for the third side. Let's find the sum. Let's find the difference. If you'd like to, why don't you pause it and try to find this on your own at this point. Now that you tried it on your own, 11 plus 7 is 18. 11 minus 7 is 4. So it's all values in between 4 and 18, but not including 4 and 18. 4 is not included, 18 is not included, 21 is not between 4 and 18, 8 is. Did the answer have to be 8? No, it could have been any value that's in between 4 and 18, but not including 4 and 18. Let's take a look at one more. Jackie is building a triangular fence for her tomato garden. She has an 8-foot piece of fence and 4, which can be the length of the third. So why don't you try this on your own? Find the range of possible values for the third side, see which those values is in between them. So pause it, try it on your own. Now that you tried it on your own, I'm going to find the sum. I'm going to find the difference. I'm going to do 8 plus 4 is 12. I'm going to do 8 minus 4 is 4. It's everything in between 4 and 12, but not including 4 and 12. So 4 is out, 12's out, 2 is not in between 4 and 12, 5 is. The triangle inequality theorem states that the two smallest sides must add to be larger than the third side. So if they give you a list of values, you take the two smallest, add them, and see if it's more than the third. If it is, they can be the sides of a triangle. If not, they can't. And a spin-off of this, if you want to find a possible value for the third side of a triangle given the other two, find the sum, find the difference. Anything in between those values, but not including those values, would work. Practice. Have a nice day.